Hello, I'm Craig Gallen, and in this simple example I'm going to show you how you can use Drools to change the severity for the alarms in OpenNMS. You can see on my screen here that I have a diagram of the scenario that we want to support. At the moment we have a user of OpenNMS that is using separate OpenNMS instances to connect to individual customer networks, and this allows them to have separate configurations to change the severity of alarms that are coming from the customer's network for that particular customer. Each OpenNMS is connected through the alarm forwarding and REST APIs to an upstream system that's consolidating everything together for the managed service provider. Now they want to move to a scenario where instead of having separate OpenNMSs, they could have a single OpenNMS with minions provisioned through an appliance on the customer's sites. This would simplify the overall architecture and would also allow them to use a single OpenNMS rather than having multiple OpenNMS instances running in their own environment. Now the problem is that because they're changing the severities of alarms, at the moment what they're having to do is to change the eventconf file in the etc directory of OpenNMS. And changing that file changes the severity of all alarms that are generated for a particular event coming into OpenNMS. So there's no inherent mechanism to allow you to change the severity depending on which customer we're talking about. There is a feature in OpenNMS called Event Translator, which can generate new events based on incoming events, and that could be used to generate new events based on events coming from the customer's network. Or indeed, we could also use the business service monitoring feature to map particular events coming in from the network into new business service alarms. However, the problem with both of those approaches is that you end up with having to write configurations specific to each customer. And what we wanted to do is create a way in which we could simply apply a category to a particular node in the network, and the alarm processing for all alarms from that node would then be mapped in a different way to the way they are normally mapped. So the scenario that we want to deliver, the solution we want to deliver, basically is using the Drools engine, which is built into Alarmd. Now, out of the box, Alarmd uses the Drools engine to process events and to deduplicate alarms. So it's already used for processing all events that are coming in and turning into alarms in OpenNMS. What we're doing here is adding a new alarm severity change set of rules which go in a single file dropped into the Drools directory that's associated with Alarmd, and that will then create a set of scenarios that manage alarms differently to the standard way in which OpenNMS runs. And that alarm severity rule uses another file called rules constants, which is a CSV file, and that actually contains the mapping of the category of the device, the UEI of the alarm, and the required severity. Now this is all very well, but we wanted to get away from having to change files in the etc directory. That in itself was, introducing complexity into the design, particularly if the system was actually running on a customer's site, which is happening in some cases. So in this scenario, we've also invented a new event, which is a configuration change event or reload mapping event, which can be injected by the REST API into OpenNMS. This is very standard. You just inject it, and that event contains in its configuration the mapping which will correspond to the new rules constant CSV. So by sending an event in through the REST API, you can change the mapping. But you can also change which nodes a mapping applies to by changing the category on the node, which again can also be done by putting a new provision requisition in through the REST API. So the net result of all of this is you don't have to change anything within OpenNMS. You can use the REST API to change the monitoring. So if I go a little bit deeper and down into the description, the actual list of that would exist within a rules constant CSV file looks like this. Essentially, you've got in this case, customer 1, which is the category that's applied to the node. Then you have the UEI, which this new mapping will apply to, and then we're saying that this will become a major alarm. So you can, for a particular event coming in, change the mapping to the severity of alarm based on the category. And there's also the ability to have a default mapping which will apply to every node. If the default is not defined, then nothing happens. But if a default is defined, then every alarm that comes in with that UEI will have this particular severity applied to it. But if a specific severity is also being defined for a particular category, in this case customer 1, then we could change that severity from the default to the major, and it will overwrite that. So the specific customer categories will always overwrite the default, but if a default is present, then all events corresponding to, in this case, node down, will be applied to default. If this doesn't exist, then the normal alarm processing that happens in OpenNMS and is configured in the event config file will carry on as normal. Okay, so I've provided a example here, which is a Docker Compose example, and you can see that in this file I have Docker Compose script. If I look at that briefly, we can see that it's a standard OpenNMS running with Kafka, and just down to the bottom, I've also defined 3 SNMP SNMP devices which are actually being used for the test. So if I turn these devices off, I'll get a node down alarm. If I turn them back on, I'll get a node up, and OpenNMS will recover. So that's my scenario. The other thing I've done is I've given specific addresses to these devices so that the configuration I provide for OpenNMS will work, because if I don't provide specific addresses, then DHCP will be applied, and depending on the order in which these nodes come up, they might get a different address. So I need to be specific about the address for my particular test. Now, the configuration for OpenNMS in this particular example is held within the configuration FS. And if I jump down, sorry, I don't need to look at the menu, I like to look at Horizon, under opt, under overlay, under etc. These are the files that are going into OpenNMS in this particular example. And these would be the same files that you would drop into your own OpenNMS if it isn't running in a Docker container. So what have I got? Well, what I've got is alarmd. Now under this file, under this directory, rulesconstants.csv is already provided as an example, but if it isn't there, it'll be created if a rules constant event is sent in. And then the rules daemon has this particular file, which is used to change the severity of the alarms. So let me look at the rules just to see how that works. And we can see that it's a standard rules file. Basically, we're declaring that externally OpenNMS alarms will be injected into this rule. And then we're declaring 2 mappings. One mapping is of the category UEI and severity to strings. This is used to read the config file. And then we also have a UEI map, which is actually a hash map. And the hash map contains hash maps. So essentially, the outer hash map is category selected. So if you've got a category, then this inner hash map is selected, and that maps the UEI to severity. So this particular map, which is declared under UEI map, is what is actually used in production, but this URI mapping is used within the definition file. We don't actually use the definition file directly. We map it into a set of hash maps, which makes it much more efficient and easier to write the code. So let's look at the rules. So the first rule is the rule which fires always at the beginning when OpenNMS starts up. And what this does is it reads the mapping file using the alarm service. And it inserts that UEI map that it has created into the system so that now we have a mapping that the other rules can use. Now, these particular rules use a set of functions, and the functions are defined down at the bottom of the file. I won't go through them in detail, but you can see here there's a write mapping file function, and it's basically Java. A function in Drools is essentially a method, a Java method. The only thing to say on this is that you have to inject the alarm service into each of these functions because it's not available directly to the function without it being injected inside a rule. So then that allows us to actually use the alarm service to either change the severity of alarms, or in this case we're using it to actually write out logs associated with something that's happened within this particular function. Okay, so finally, the only other thing to say on this is that functions do not support generics in the function call. So in the signature of a function, you cannot put generics. You can put them in the return, but you can't put them in the actual signature in Drools. So what happens is that we're actually using casting to actually be able to use generics inside the rule, but we don't use it in the actual call of the rule. That's just a little bit of detail for you. So let's go down and look at the next rule. So the first rule is just going to load the file. The second rule is to load a new alarm mapping, and in this case, if we receive an alarm with the reload mapping UEI, then it will look in the description field within that alarm, and it will take that description as a CSV parameter, and it will actually turn that into a file to be put in the alarms directory that you saw previously. It will also update the rules. So if you inject a new set of mappings using this event, you update the file, which means that those mappings are persisted, but you also update the rules engine, which means that those rules are immediately applied whenever a new mapping is injected. Okay, so those are two rules that are provided, one to load and startup and one to respond to a reload mapping event. The rule that actually does the work in this particular scenario is this rule here, the change alarm priority rule. And what it does is it looks for any alarms which are problem type alarms and are not cleared. If they're cleared, we don't want to change their priority. We want them to be deleted from the system as normal. But if they're not cleared, then we might want to change the priority. So what we then do is we use a function which uses the category that's been found from the node associated with this alarm. It uses the UEI map, which we injected previously, and it uses the last event UEI. So what we're taking from the alarm is the event UEI, which basically says what alarm is this. We're using the UEI map, which is the mapping of alarms to categories, and we're using the category that's taken from the node, and we return a string. So if this function returns a string, then the rule will carry on. If it doesn't return anything, then the rule ends there. So once the rule carries on, then what we do is we put out a bit of a log message, and obviously in production you probably want to change this to debug and change the alarm mapping, the log4j file accordingly if you want to get this thing showing, but I'm just doing it as warnings here because it just makes it easier to see what's going on without changing everything. So if the OpenNMS severity names contains new severity, this is basically saying that I'm checking that the OpenNMS severity enum actually contains the new severity that we've put in the file. Then we will apply the rule. If it doesn't, then we'll just put out a warning, cannot apply a severity that we don't know about. And then we create a new severity, and we essentially go through a test here to see if the OpenNMS severity in the new alarm corresponds to the existing severity. If the alarm has the severity that we want, then we don't want to change it because it's already been changed at some point. So we just ignore the rule. But if it equals the new doesn't equal the new severity, then we set the severity of the new alarm, and that's the end of the rule. So hopefully that makes sense. Essentially 3 rules in one file that are used to both load a new configuration and also to look at changing severities as they come in, as alarms come in. What will be useful now would be to actually look at this running. So if I look at my list of alarms, I do have some alarms here because the SNMP data collection isn't working for these particular nodes. That's fine, that's what I expect. What I'm going to do now is I'm going to basically, if I show you in my Docker Compose file, which is running, you can see here Docker Compose up -d. I'm going to cause the node SNMP3 to stop. So if I do a Docker, we can see that those are not there anymore. So we are down. Now it will take OpenNMS a little while to work this out because it's scanning these nodes, and the node down alarm will only come in once the nodes are actually detected as down. So we can see here now that the alarms are down, the nodes are down, and we can see that these two have been mapped to critical, and this one has been mapped to major, which is what we actually expect in our scenario. If I bring the nodes back up again, these will clear. Now, what if I want to change the mapping? Okay, well, I'm using rester here to inject a node down alarm. So this is the mapping that's already there. What I'm going to do is I'm going to change that one to warning. I'm going to change that one to critical. Okay, so I've changed the mappings of this. I'm going to send this into OpenNMS, and now I'm going to look at the alarms and just reload the file, and you can see, look, the criticality has changed for these alarms because I've changed the mapping. And if we looked at the mapping file, we'd see that that had changed and that the mapping was now different in OpenNMS. Okay, so just to summarize, we have shown that you can create a mapping file using this event. We can change the mappings in alarms based on that event file, and we've got the nodes down. We can bring the nodes back up, which I'm going to do simply using a Docker Compose up. And with those nodes back up, these alarms should now clear. And you can see they've cleared. For any more information on OpenNMS or to ask for services or help, obviously our OpenNMS website is available. Please go there, and any extra information you require on this particular thing, or you want to reach out to me, then please reach out through the GitHub example that I've shown you. Thanks, Anne. Bye.